In this video, I'm going to explain you basics of Kubernetes and show you a demo on how it works. My name is Matúš, I'm senior software engineer with more than 7 years of experience, and I spent past 3 years working on projects that run on Kubernetes. So let's start with what is Kubernetes. Kubernetes, often abbreviated as K8S, is an open source container orchestration platform that automates deployments, restarts, scaling and load balancing. How does it work? You basically define what you want, for example, free replica sets of a web server, and Kubernetes makes it happen. Kubernetes architecture consists of two main parts: master node, aka control plane, which is the brain of the Kubernetes, and work nodes. Main parts of control plane are API server, central hub that all requests go through, for example, requests from kubectl or from UI. Control manager, it watches cluster and make changes to achieve desired state. For example, it create pods, handle restarts, etc. Scheduler decides on which node to run pods. etcd, which is key value store that holds all cluster configuration and state. Worker nodes are nodes where workloads run. They consist of kubelet agent that talks to API server and ensures containers are running as expected. kubeproxy handles networking and load balancing for services within cluster. Container runtime is software that actually runs the containers. It can be, for example, Docker. Key Kubernetes objects are pod, which is the smallest deployable unit, typically container. Replica set is an object that keeps specific number of identical pods running. Deployment is object that handles interchangeable pods that are load balanced. Stateful set is object that handles unique pods, each tied to its own data. Service is stable network endpoint to expose pods. Ingress manages external HTTP and HTTPS access to services. Config map and secret are used for storing configuration and sensitive data. Persistent volume claim and persistent volume are used to provide persistent storage to pods. The demo will have two parts. The first one will be definition of deployment with multiple replicas. This demo will show us ability of Kubernetes of self-healing and load balancing. So let's start with the stateless application. We will need to define deployment. In this case, we will use, for example, free replica sets, and we will deploy Nginx web server, and here we are exposing port 80 where the server is listening. As the Kubernetes cluster is running on my laptop, in order to reach out to the pods, we need to create the service. The service will be of type node port, so it's exposed outside cluster, which means also to my laptop. And here we will mapping ports 80 that will be exposed to cluster to mapping the incoming traffic to target port 80 with inside the container where the Nginx web servers will be listening. Now let's apply the configuration. The resources were created. Now let's list the pods. And as we can see, there are 30 pods running, as we define 3 replicas in the configuration. Now we can demonstrate self-healing ability of Kubernetes orchestration by deleting a random pod. So let's delete the first one in the list. The pod was deleted, and now when we list the pods again, there are again 3 pods, but this time there is a new one which has age of 5 seconds only, because it was created 5 seconds ago. Now let's list the created service, and we can see our service here, which is of type node port, and as this is running on Docker desktop, the node ports are automatically mapped to port on my local machine. So it means I could be able to reach out the service via localhost in this port. So let's give it a try. And as you can see, when I'm reaching curl, we got here welcome message from Nginx. In order to demonstrate load balancing, we will adjust content of index HTML file of every Nginx server, and we will then iteratively send curl and see which one will be responding based on selection done by load balancer. So the first one will contain hello from A, the second hello from B, and the third one will contain text hello from C. And now let's reach out to the curl in loop and see which server will be picked by the load balancer. And we can see it was the third one, then the first one, then second, third, first, second, third, and etc, etc. So this is a great demonstration of the load balancing. The second part of demo will be about stateful application, where we will use stateful set and persistent volume. This will demonstrate ability of Kubernetes to persist data over pod lifecycle. So let's start with the definition of stateful set. As you can see in kind, we define stateful set. We name this stateful set Postgres because we will run Postgres database. In the container definition, we define image for Postgres. We add there some configuration for the database, and the most important part is volume mount, where we are referring to Postgres storage, which is volume claim template that we create below here. And we define mount path, which is directory where the persistent volume will be linked. And in this case, it's varly Postgres data, which is where our Postgres database store the data. And in the volume claim template, we defined size of a storage, its name, and other data. Now let's apply the configuration. And we can see that stateful set was created. We see that pod was created based on this stateful set definition. Also, we can see that the persistent volume claim was created as well as persistent volume itself. Now let's store some data into Postgres database for the demonstration purposes. With this command, we will create table named test. Let's check if the table was created. And we can see that table name test is there. Now let's list our pod. This is our pod, and let's delete it. The pod was deleted. It should be automatically recreated based on the stateful set definition with one replica, and it was recreated. Let's check the pod. It's here and just 14 seconds age because of it was recreated. Now let's check if the data still persisted over the reconciliation of the pod, and we can see that the data is still in the table. So that was the demonstration of persistent volume. That was Kubernetes. If you liked the video, please check my other videos. Thank you. Bye.